Right now we have this pretty basic website, but at least it looks good, it's responsive, and we didn't put much effort in because we just copied off of the Bootstrap documentation. The problem with this website though is that it's static, which means it's never going to change. This kind of website would be good if we were developing it for a startup or a contractor or a plumber or a bricklayer, something like that, who would want a website that doesn't really change, where they just maybe have to update their phone number every now and then. But for our purpose, what we would like is we would like this list of users to grow as people register for the website. So we can't stick to this static website. We're going to have to go a little bit further. At the moment, if we wanted to add in an extra user to our page, we'd have to go back into our code and manually add in an extra user. So I've just copied one of the users and I've changed him to user 4. Save it. If we refresh the page, we'll see that we have an extra user. We don't want to have to do that. If we had 1,000 users, we'd have to go back into our code and paste that 1,000 times. And every time someone would register, we'd have to go back into our code and then add it again. We don't want to do that. What would be cool is if we could somehow have the website automatically generate this list of users for us. But we need to think about how exactly this is going to work. To start, let's focus on what's happening right now. When I refresh the page, Google Chrome opens up the index.html file on our computer. It does this using the file protocol. If we double click on the URL bar at the top, you'll see that the file :/ is written before the location of our file. This basically tells Google Chrome to directly access the file from our PC. Let's test this out a little. Let's edit the website in Google Chrome and see what happens. What I'll do is I'll change the header of the website. I'll change it to say Dan Bardo, and let's see what happens. Oh, cool. It looks like it's changed. Let's see if it's permanent. Let's refresh the page and see if the Dan Bardo stays. It didn't work. It's not permanent. And it's because we refreshed the page. When we refreshed the page, Google Chrome went back to the original index.html file and loaded the content. This picture roughly shows what's going on here. We have our browser Google Chrome, which directly accesses the index.html file from our PC. Our PC passes the file to Google Chrome, and Google Chrome renders it for us to see. Now, if we make any changes to the website within Google Chrome, the changes stay within Google Chrome. If we refresh the page, then Google Chrome asks our computer for the file again, and our computer returns it. Then it re-renders the same website. Now, what we'd like is to add in some extra steps here so that the list of users is automatically added to the index.html file before it's sent to Google Chrome. So, for example, Google Chrome would ask for the file, and then the file would get prepared, and in that preparation, we would include all of the users inside of the HTML. Then the file will get sent back to the browser, and the browser would render it with all of our users included. Now, before we try and figure out how to make that happen, let's take a look at what the process is for normal websites. So if we go over to google.com, you may have noticed that there's a HTTPS up in the place of where we saw file before. HTTP stands for Hypertext Transfer Protocol, which is different to the file protocol. Basically, HTTP is a protocol that's used to transfer information between browsers and web servers. The S at the end tells us that this is the secured HTTP protocol, which means that all the information that's transferred between our browser and any web server, in this case google.com's, is encrypted. Every time we try to access a website, what's actually happening is that our internet browser is sending out a message using HTTP to a web server somewhere in the world. In this case, our browser is sending a HTTP request to google.com's server. If we try to search for something on Google, we'll end up sending another HTTP request to the Google servers, except this time it'll include our search term. So if we search for apples, our HTTP request will include the word apples, and that would instruct the Google server to search for everything related to apples. What we'll do now is we'll have a look at exactly what these HTTP requests might look like in this situation. So here's a simple picture of the situation, and what you can see is that first the browser sends a HTTP request to the server. After the server processes the request, it sends a message back to the browser, which is called the HTTP response. Both the HTTP request and the HTTP response are made up of two parts. They have a header and they also have a body. The headers within a HTTP request basically tell the web server what to load. They can also include extra information such as cookies and constraints. In this case, we're trying to load the website google.com/, and the request type is GET. There are quite a few different HTTP request types, but the most commonly used are GET and POST. We'll talk about these a little bit more in later videos. The body or payload of the HTTP request contains more specific information about the request. For example, here we are searching for apples on Google. So an extra piece of information has been included in the body of the HTTP request to tell the server that our search query, Q, is apples. The response header tells the browser whether the server successfully performed the request or not. In this case, the server returned 200, along with lots of extra information about the response. Here, the 200 is called the HTTP status code, which in this case tells the browser that the request was successful. There are lots and lots of different status codes, and each correspond to different problems that a server might face. For example, a common status code is 404. If you see that you have a 404 error, that basically means that the server couldn't find the page that you were requesting. The response body will typically contain the HTML to be rendered within the browser, but it can also contain data in other forms. Okay, now that we have a basic understanding of what a HTTP request or response will look like, let's have a look at these requests within Google Chrome. So at any time in Google Chrome, we can view all of the HTTP requests and responses. All we need to do is right click and click Inspect Element, and within the Developer Console, click on Network. What this will do is it will record all of the HTTP requests that are sent from our browser, as well as all of the corresponding responses. So at the moment we can't see anything, but if we refresh the page, we will see all of the requests. In particular, this first request is the one that's responsible for loading up the Google web page. If we want to see more information about it, we can simply click it, and Google Chrome will show us both the request headers and the response headers. As you scroll through the request headers, you'll notice that it's very similar to what we saw in that more simple example, but there's also quite a lot of extra information here. If we have a look at the response headers, it's the same. There's quite a lot of extra information, but the status code is still there. So we still got a status 200 to say that the request was successful. If we want to view the response body, we can either click the preview button to view it as you would see it in the browser, or you could click response to view the raw data that was sent. So here you can see here is all the HTML code that was sent back to us from the Google servers. Now let's try that again, except this time we'll search for apples. And when we look through all of our requests, we'll see the first request is directed to this search file. And what the Google server did is it extracted our search query, our search term apples, and it used it to generate this special web page just for us, which shows all of the results related to apples. This picture gives a rough idea of what's happening here. The browser sends a HTTP request to the web server, then the web server decides what file to look for depending on the information present in the HTTP request, and that file could contain some form of code. And if it does, the web server will compile and execute that code. And in this case, the code must involve some kind of search functionality. So what it could do is it could interact with a database to perform the search and then construct HTML based on the results. So construct HTML that will include all of the results about apples for us. Then after the server has compiled and executed the code and has its HTML prepared, it sends the HTML in a HTTP response back to the browser. Now, the language of the code that's used on the web server will depend entirely on the web server. There are many different types of servers out there, and there are many different server-side languages that are commonly used. In this case, I've mentioned the language PHP. Anyway, this is exactly what we need to happen for our website. So that means what we're going to have to do is construct our own web server, and there are many ways that we can do this, but in this series, I'll do it using PHP. So in the next video, we're gonna install PHP on our computers.